Alright, now in the previous lecture we have learned what's a queue and what type of applications can use it. Now in this lecture, let's see what are the standard operations that can be performed on queue data structure. Basically, these are the 7 operations that can be performed on queue data structure that are create a queue, enqueue, dequeue, pick element from the queue, check if the queue is empty or not, check if the queue is full, and finally delete the queue. So before going deep into these operations, let's see what are the implementation options we have. Because depending on the implementation, the declaration of these transactions will be changed. For example, in case of linked list, isFull method is not required at all. Similarly, there are variations in other methods as well. So the queue can be implemented in 2 ways in Python. It can be created using Python list, it can be created using linked list. In case of Python list, if we set maximum size, the queue becomes time efficient, otherwise lists are quite so slow for this purpose. Because inserting and deleting an element at the beginning requires shifting all elements one step left, so this takes O(n) time complexity. If we are using Python list to create queue with the capacity, it becomes circular queue. And the second case is linked list. We will look at all these cases in this lecture over here. The typical queue looks like this in terms of Python list. Here basically we have a Python list, we have some elements in it. So here we have some blanks as well. So we can insert some elements and we can remove elements from this queue. In the world of queue, we are not using insert. Instead of it, we use enqueue, and instead of remove, we use dequeue. Similarly, if we implement a queue using a linked list, it will look like this. And each node has a number assigned to it. So here you can see each node has a number in it. Now we have learned the queue can be implemented in 2 ways. Now let's see how queue method works. The first method is create queue. So here to create a queue, in case of Python list without capacity, we just initialize an empty Python list over here. As you see, we are initializing an empty Python list and it is in the memory like this. This means that we can insert as many as element that we want. So we have an empty queue over here. So let's insert some element to it. As we mentioned, insertion in the world of queue is called enqueue. So we will look at enqueue method. So when we insert the first element in the queue, it's located somewhere in the memory in random location. So in this case, we are enqueuing 1 to do this queue. So it's located in the memory like this. Now if we insert second element, it will locate it after this element in the queue. So every time when we are inserting an element to the queue, it will be located at the end of this queue over here. So as you see, it's coming here. So if we insert third element over here, it will be located after 2 over here. So if we enqueue 3, it will be located like this, and it will continue like this until the last element that we want to insert. So as we said, in case of Python list without capacity, we can insert as many as element in this case. But this is very time consuming because in Python, when we reach default capacity of the list, the relocation might occur and this will take O(n) time complexity. So here we need to take into account that we cannot insert any element between these given elements over here. All we can do is to insert element at the end of queue over here. And if we create a queue capacity when we create a queue and try to enqueue elements when the capacity is reached, it will raise error saying that the capacity is full. Now we have inserted these 4 elements to this queue over here and the elements are located behind each other. Now the next operation, dequeue operation. As we have already said, in the world of queue, instead of remove, we use the queue word over here. So here we have the same queue that we created. So we have inserted 4 elements to this queue. So if we perform the queue operation on this queue over here, it will return the first element and this element will be removed from the queue. So as you see, the first element is removed from the queue. Now the first element is this one. Now the first element is 2. So if we run the queue one more time, it will return 2 and 2 will be removed from the queue over here. As you see, here we have FIFO method, which means that the first element that we inserted comes out first. So here, the next element is 3. So if we call the queue method one more time, it will return 3 and 3 will be removed from here. And finally, we have only 1 element in the queue. So if we run the queue method one more time, it will return 4 from here and 4 will be removed from the queue over here. Now the question is, if we run one more time the queue method in case of empty queue, what will happen? In this case, it will raise an error saying that The queue is empty. So let's continue to the next method, which is pick method. So here again we have the queue that we created before and we have inserted elements to it. So the pick operation is very similar to the queue operation. The only difference is that beginning of the queue will not be updated, which means that we are not removing the first element from here. This method returns the first element from the queue, but it's not removing the first element. So when we run several times pick method, the first method will be returned. So every time it will return 1 over here. But here if we perform the queue method, it will return 1 and 1 will be removed from the memory. And after the queue method, if we perform pick method, it will bring us 2 because 2 now is the first element in the queue. So you might be interested why we need pick method. In some application, we just might want to check the first element in the queue without removing it. So in this case, pick method is very useful. Now let's continue to the next operation. The next operation is we check if there is an element in the queue or not. This is empty method. So this method is used inside other methods to check elements in the queue because if there is not an element in the queue, it does not make sense to perform the queue or pick methods. So inside the queue and pick method, we are using this method to check if the queue is empty or not. So in our case, if we run this method for this queue over here, it will return false because in this case, it's not empty. If there is not any element inside this list over here, it will return true. So the next operation is full operation. As I mentioned, in our upcoming lectures, we will create a queue with capacity. In this case, we can use this isFull method because when we reach the capacity, we cannot insert any element. So we are using this method inside in queue method because when we are inserting elements to the queue, we are checking that if the capacity is reached or not. If the capacity is reached, we are saying that the queue is full, so we cannot insert any element to this queue. But in our case, without capacity, we don't need this method over here. So we are not using isFull method for the case of Python list in which we are not setting capacity. Finally, the last operation is deletion of entire queue. So to delete an entire queue, we need to set the list to empty list. So with this, all elements of the queue get deleted from the memory. So this is the last operation for the queue. So in this lecture, we have learned queue operation in case of Python list without setting capacity. Now in the next lecture, let's create a queue in practice using Python programming language. See you in the next lecture.